Well, welcome everyone. Great to have you here and happy Thursday. My name is Zach Semke and I'm director of Passive House Accelerator. And we are really excited about today's component spotlight with Solveig Ray of Cascadia Windows and Doors. She'll be presenting Window of Opportunity, leveraging Passive House windows in commercial and residential buildings. I am going to be playing the role of Q&A concierge today. So as questions occur to you during the presentation, please type them into chat and we'll be tracking those and creating a queue of questions, and we'll get to them during the Q&A session. So without further ado, I am very happy to introduce Solveig Ray, who is a member of the Cascadia Windows and Doors technical sales team. She's a certified Passive House consultant with background in mechanical engineering and more than a decade of experience in high-performance building products. Solveig routinely works with Cascadia clients to optimize their product configurations and specs to maximize their project's fenestration performance. So with that, I'm going to hand it off to you, Solveig. Thank you.
Thanks, Zach. Excited to be here today. I got my Passive House accreditation. It feels like a long time ago, but it was only 5 short years ago, and I've been admiring Passive House Accelerator, what you guys do ever since. So yeah, thank you so much for having us on here. All right, on with the content. So today's presentation, not about me, is about, we're going to start with an intro to Cascadia and who we are. Some of you may have heard of us before, but may not be familiar with exactly what we do and how we are changing the world. And then these first 4 points: importance of windows and Passive House, meeting the Passive House standard, key elements. I'm hoping it's more, for this audience, it's more of like a quick overview. We're going to kind of blast through to get to the real fun part, which is real project examples in the real world that you can learn better about how to use our fiberglass windows. Okay, so at Cascadia, we manufacture exclusively, high performance building envelope components, all made of fiberglass. And those components include what you see here, windows designed for the institutional, commercial, multifamily, big building space. Don't be sad, any of you from the single family world. We sell a ton of residential windows, but this is what our windows are designed for. On the right, you can see the Cascadia clip, which is the second weak link in the envelope, which provides thermally broken cladding support as we move to exterior insulation. So we have total, dedicated webinars exclusively to that topic. I encourage you to sign up for those to learn more. We're going to be focusing on windows today, though. So we're not only a product company, but we are also consider ourselves a technology firm with the mission of leading North America's transition to energy efficient and durable building design by using fiberglass. So here you see a beautiful image of our Universal series to give you just a little history on where this came from. We had a crisis in the construction industry in BC where poor air and water management in windows and thermal performance created a massive problem in building envelopes called the leaky condo crisis. And the reinvention of a commercial grade window that handled this with a rain screen design, but then also met the future needs of commercial buildings and energy performance standards that were coming, with Passive House as the target. The founders of Cascadia saw that coming. And so this Universal series is designed to meet both of those requirements. And it's really the first of its kind to be designed, built, manufactured, and PHI certified in North America. The use of fiberglass also has these side benefits. So you can see the sticker, red list free, non-toxic, low carbon, all that good stuff, which I'll go into more later. So as we probably all know, Passive House certified products here. And you'll be interested perhaps to know that the Universal series got this nice prize for aesthetics and innovation when it was launched in 2019 at the International Passive House Conference. So enough about us. Let's go into some interesting content. You're looking at the Bush School in Seattle in that image. It's the first FIAS school in Washington State. And to start out with, I was hoping to get to know a little bit my audience. and have you, first of all, put down your coffee and tell me what your experience is. How many newbies are on the call today versus how many of you are gurus, seasoned Passive House experts?
This is really interesting. This is great. I'm so glad that you're doing this poll. So far, we have 78% people have responded, and 61% of folks on the call have never done a passive house. 26% have done 2 to 5, and 6% have done 6 to 10, and 6% have done more than 10. So more than half
Real
of us
range.
have not done a project yet, a passive house project, and then it goes on from there.
Okay, that's great. Thanks, Zach. That's very helpful because I can tell you I'm not going to go into deep dive into passive host criteria for Windows. However, I'll let those newbies know that I do a completely separate and dedicated webinar that's AI credited, just focusing on passive house for Windows. And it's really a good like refresher of what you learn in the course. So I encourage you to sign up for that one separately. So I'm sure everybody has seen this graphic before. It's just the most used graphic ever for passive house. And our passive house buildings achieve incredible energy footprint reductions over typical buildings by focusing on all of these key principles in the bubbles. But just note that windows have their own bubble, and that's for a really good reason. They are the weak link in the envelope, and we really need to pay a lot of attention to them. This is just a selection of jurisdictions in North America that have recognized the effectiveness of energy performance standards like the Passive House standard and have encouraged or incentivized project teams to pursue this kind of energy performance-based path, either as a part of permitting, so with increased floor area allowances, for example, funding, financing options. And this list is growing all the time. You can see City of Vancouver on there is a great example. And I'm a little segue to this slide, which if any of you attended the Passive House conference in Victoria last year, the City of Vancouver presented this information as part of their learnings. The City of Vancouver has actually mandated that all of their buildings going forward will be built to the Passive House standard. And this is a little bit of the story why. So if you're looking at this graph, it is the essentially energy performance in kilowatt hours or kilowatt per meter squared per year. And it's all of their operational building stock. So they have the data to show how all of their buildings are performing old and new. And the interesting thing that they pointed out was these dark blue lines here. These are all brand new LEED Gold or Platinum buildings. So theoretically sustainable high performance buildings. And they do not hold a candle to the low energy footprints that they have seen from the brand new Passive House certified buildings in this teeny little box in the bottom. So you can see that box is blown up for you there. Interesting fun fact, most of these buildings have Cascadia products on them. So another beautiful shot of the Bush School. Let's talk about the standard briefly. So we have a bunch of criteria that windows and the building have to meet for the Passive House standards: thermal comfort and draft prevention, hygiene, air tightness, and thermal performance. Now, the first two are ultimately what we are trying to achieve with Passive House. And believe it or not, the other two are the means to the end of achieving it. And so that's the goal: health and comfort of occupants, along with thermal performance. Now we can use certified products on Passive House projects or not. Do not think that you are limited to what is shown on your certificate, provided you have a product that performs at a Passive House level, such as what I'm showing you here, a standard triple glazed window from Cascadia, and you have the modeling to back that up and put into PHPP. You have the flexibility to do what you need to with your design. You, of course, can go to a certified configuration. That's a lever that you can pull when you have the option. Typically, it increases costs. So again, it's a lever that you can pull. And the reason why is because PHPP is a very detailed modeling package that the actual configuration of what your windows are matters. So each condition has to be put into the model in order to get accurate performance. So having a product and company that provides that modeling is important to facilitating that process. And thankfully, Cascadia, we do that. This is just a snippet of some of the non-certified conditions that we've had modeled that we provide to architects and modelers to enable them to complete their modeling for commercial projects. Okay, here's the poll that we wanted to do later. So we have a lot of people that are new to Passive House, but maybe not new to fiberglass windows and Cascadia.
We just passed 2/3 of folks responding, and 12% of folks say never heard of Cascadia. 65% say know the name, but not much about Cascadia products. 11% have attended a Cascadia webinar, but haven't specified products. And 11% have used Cascadia products on a project.
All good news. Great. Makes me glad I haven't used too much recycled content for those who have been to our webinars before. Okay, so at least our strategy at Cascadia, we think this is kind of a universal strategy to get the best value out of really any component, but windows in particular, is to focus on maximizing or optimizing these key elements, especially within the Passive House context. So we want a really great design that is set up that lends itself to high thermal performance while also achieving the other things, functionality, capability that you need from a commercial grade window. We need performance, not just thermal performance, but all around performance. We also want to maximize lifespan. I think intuitively everyone knows that the longer something lasts, the more value we get out of it, right? But that's unfortunately not always the first thing we look at. So all of those things combined give us value. I'm going to go through each of these things next, starting with design. So the Cascadia Universal Series is designed from the get-go for triple glazing, Passive House standard, and this is at commercial sizes without compromising on glass thickness or anything like that. So you want a window that can handle all the glass that you need for your project type. So you're going to have 2 to 3 low-E coatings and typically argon fill in that unit, as well as a warm edge spacer. This is the weak link of the weak link. We've got a thermal bridge here, so we want to only warm edge spacers in increasing levels of performance available. Multiple gaskets, we want to have that any air cavities broken up. We don't want convective heat loss in there. We want maximum air tightness. So lots of gaskets. And insulated frame. Air gaps are bad for heat loss. So all those frame cavities full with insulation. Just a note, which I'll come back to multiple times, depending on your product that you're looking at, that PHI certificate will not show anything in there other than insulation. In reality, depending on your configuration and size, you will likely have reinforcing in there from other products, in particular vinyl products as size increases. Multi-point locking, we want a compression seal, no sliding seals. This needs to seal like a boat hatch for maximum air tightness and water penetration resistance. We want to minimize the frame area. So a window that's designed to be sleek and low profile as we can to minimize that heat loss area, but also deliver structurally for the commercial market. Okay, now let's talk about performance. I'm gonna go through some materials properties, especially for those who aren't familiar with fiberglass. It really explains why it's the material that we focus on for our products. So starting with conductivity, easy, obvious one. You can think of these as holes in your energy bucket. This is the conductivity of different materials. And you can see that the aluminum circle over here, that is 1,000 times more conductive than our PVC, fiberglass, and wood frame materials. So that is a big hurdle to overcome when you're designing a window for Passive House performance. It's going to require a lot of effort, engineering, and thermal breaks to make that happen. Our next property is strength and stiffness. This determines the bending strength. Young's modulus or modulus elasticity determines how big your window can span. I've got steel up there as the reference material. That's our structural material at 200 gigapascals. And then our frame materials below. So just looking at this, you would think that, PVC might not be able to make a window out of it. Well, guess what? It gets reinforced with other higher conductivity materials, compromising its thermal capabilities. Aluminum, likewise, very strong, compromises its structural strength by adding in complex thermal breaks, and that brings it down. So just note, fiberglass is nicely in the middle here, kind of set up for success. The thermal expansion coefficient, it determines how much your material expands and contracts relative to temperature. And it's not often thought about, but very important, since these windows are complex assemblies with many different components inside, including our glass unit. And then we have our frame down here, wood, fiberglass, aluminum, and PVC. So in the factory, everything fits nice. And then as soon as we change our temperature, the thermal cycles begin, expansion and contraction. So why do we care? There are seals and joints between all of these components that are critical to maintaining the performance. We want to keep our Passive House certified performance. We want to keep our water penetration resistance. So this matters. Quick note here that wood looks pretty good here on the scale. However, yes, thermally it is, but for relative humidity, it is not. Wood changes dimensionally dramatically with relative humidity. And of course, fiberglass is almost the same as glass because it's mostly made of glass. So minimize stress. And here's just a visual of that, of kind of the impact of dimensional change. You can clearly see that depending on the extent of this deformation that happens in these materials, you can get premature failure impact to performance. And this is really comes from the difference between a thermoset material like fiberglass, which is cured and kind of an irreversible chemical bond that happens, versus the thermoplastic or thermal molded, melted material that uses heat in order to change its shape. It makes them more susceptible to this. So it's a common theme. So last aspect on my value topic is lifespan. So I think many people think of lifespan as a binary thing. Oh, like it performs until one day it doesn't. But that's not always the case. We have to think about how long, yes, until I have to ultimately replace this thing, but also how long can I expect it to perform as designed on day one? And then what is the impact of that lifespan from an energy and carbon standpoint? This is a very dramatic visual of the impact of short lifespans. This is taken directly from that leaky condo crisis I mentioned. This kind of failure was happening at that time in, less than 10 years, just horrendous. But, this is what happens when you have envelope components slowly failing under the surface over time. So stretch that out, and that's what building failure looks like. And windows can be a source of that. So we want to maximize that lifespan. From the energy side of things, this is a graph of, I guess it would be embodied energy. You have the production energy of a different window type, and then the replacement energy to replace those components, as well as, intermittent additional replacements over time. So basically here, having a component that gets replaced more frequently can undermine the overall energy improvements that you're hoping to get from that product, if you're just thinking about operational energy. Fiberglass here, low input energy, long lifespan. And from the embodied carbon side, we are seeing more projects that are looking at this aspect. This is an example done by ZGF Architects here on the Pacific Northwest, mass timber building. They wanted to see what the impact of the choice of window materials was. You can see in that first image that there's over 30% improvement by using fiberglass over aluminum on in this particular building. Now, this kind of analysis is really important, but it's only made possible by the data that we have available. So a quick note to those considering life cycle analysis on their buildings: you need EPD data in order to do that. Cascadia has an EPD. I could do a whole separate chat all just about EPD and embodied carbon, but I'm just going to give you a few quick notes here to think about. Yes, ask for the data. It's out there in increasing amounts. However, you need to check the PCR or the product category rules that your EPD is based on. These, just like any standards, they have base assumptions, dictate what's included, what's not. Otherwise you could end up comparing something that has no fasteners or hardware in it to something that has no glass, for example. So check those details. Check the date. EPDs are only valid for 5 years and then they have to be renewed. So there's lots of EPDs out there that are based on old PCRs, not the same rules. And then, of course, confirm the stage that you're looking at for any material. Is it cradle to gate? Is it cradle to grave? These things are not comparable, so be aware. Okay, so in summary, taking all these things together, yes, we get value, but ultimately when we're working on passive house projects and projects in general where there's a whole building energy model and we're looking at the whole building, it's no longer the window against another window. You're looking at the window against the rest of the building. What does that, by optimizing those windows, does it get you in terms of value elsewhere and flexibility elsewhere in your design, like insulation, mechanical systems, etc. All right, now let's move on to some project examples. Okay, first example I'm going to show you of Cascadia being the key to the success of a passive house project. This is a childcare center in downtown Vancouver. Coincidentally, one of the projects that was shown on the City of Vancouver slide. And the challenges that Cascadia helped out with here was that it's got a lot of non-certified configurations. This is, you can see there's storefront here. We've got also space constraints where the client needed outswing windows. Not a lot of PHI certified outswing windows out there. So really, meeting the sort of commercial nature of these windows at the PHI level of thermal performance was key. Now, next project, this is the Ken Sobel Tower, otherwise known as 500 McNabb. It has been featured in many case studies, probably on the accelerator, presented many times. It's sort of a trailblazing project, first interfit, largest project of its kind. So I'm going to use it as a little bit of a launching pad for a few topics because there were a lot of learnings that came out of this project and innovation. So first of all, I think there were two major challenges on this project that Cascadia helped with specifically. First of all, balcony thermal bridging and window support thermal bridging. And I'll show you more about those. So here we have a existing concrete structure, just leaking out heat everywhere. That is, I think, relative to the other issues, easy enough to solve just with the whole building insulation wrap. However, those balconies that I'm highlighting on the left side there, not so easy to just wrap around and get rid of. So the solution for this project, the only solution to make the energy model work was to chop them off completely and replace them with Juliet balconies. You can also see that the windows are pushed right outside of the structure, but I'll come back to that. So the solution was a third-party Juliet balcony that was integrated into the Cascadia window system. So you can see here, this is an in-swing tilt and turn window, full height, reinforced to accept those Juliet balconies. And by the way, they're really big. They're over 10 feet. So the structural capabilities do that while maintaining the thermal performance was key. And Cascadia was, of course, side by side, every step of the way of this project, assisting with the design and the modeling and engineering required to make this solution work. All right, now let's fast forward to a newer project with some very similar challenges. Feast your eyes on Cole Harbour Phase 2. This is soon to be the biggest passive house project in BC, a mixed use building, very big. Also with the challenge of balcony thermal bridging and very large openings, similar to Kinsobel. However, unlike Kinsobel, this is a brand new building. So the designers were able to optimize everything to what made sense for the building from the get-go. So what was done in this case was an integrated Juliet balcony. They said, we don't need balconies. They're a thermal bridge that we cannot mitigate. And thankfully now Cascadia has an integrated laminated guard Juliet balcony that is very, high performance, in addition to being much more cost effective than those sort of bolt-on type Juliet balconies. So one thing to also note here, you can see the top rail. This is a code requirement for the city of Vancouver, but it's not necessarily required on your project, depending on where it is. It could be just like this glass. Now, it's hard to tell from just the pictures, but this is a very large building with very large openings. And you can see there are these highly, insulated opaque areas. And this is accomplished with Cascadia's window wall system, which was did not exist at the time of the Kinsobel Tower. So I'm going to quickly pop out of the presentation here and just give you a quick intro to window wall for those who do not know what I mean. Let's pop over to the Cascadia website here. So this is window wall, continuous glazing, a mix of vision and opaque area that covers the slab. And let me just quickly show you this video. This gives you a brief intro. Okay, so it's hard to tell for people who aren't familiar the difference between window wall and curtain wall. But it's because they're both continuous glazing systems. But where window wall differs is it actually rests on the slab like this. You can see the Cascadia Universal Series here in fiberglass with an extension on the outside to permit that continuous glazing and fully insulated bypass area. Additionally, at the head of the window, there are additional components which allow for increased deflection capability needed for high-rise windows and continuous glazing. All of this is thermally broken, made of fiberglass, no change or compromise to the passive house thermal performance. Also, this is a factory-built system, unlike curtain wall. So each piece is built in the factory and is assembled on site, allowing it to be installed quickly and efficiently. Some of the other, features of this system are fully insulated corner posts. You can see here with mineral wool. And then I'll just jump to, this is the glazing area is, passive house level thermal performance still is maintained with all of the opener capability. And I'll just quickly mention the opaque areas here. You have a slab bypass, which is a massive improvement. This is a typical weak link for any system. You're expecting, R8 to up to R19 for these opaque areas. With a typical window wall made from aluminum, these are R1 to 2. So just a really huge improvement and dealing with the weak link. So you can see this video in its entirety on our website. I will jump back to the presentation. And I don't know who scribbled on my screen, but there's some scribbles. Are you guys seeing the scribbles?
I'll work on removing the scribble. It's like when we have the markup thing enabled, and then I notice it. No, there's another one. All right. Please refrain from scribbling, people.
I can I can continue with the scribbles, but mildly distracting.
Thank you for the patience, because it may take me a bit to figure out how to erase them. My apologies.
No, it's all good. They're almost pointing to what I want them to point to. All right, so back to Cole Harbor, we've got the window wall, as you can see there, with the mixture of opaque and vision areas. So that is slab bypass plus backpan areas, as well as parapet. So above the window, that's the parapet areas. We've got corner configurations. And by the way, these are really big. So you can see this little man up here for scale. And also a thing to note, none of this shows up on a PHI certificate. We could not put this on a PHI certificate. There's no PHI certified window wall. You can have curtain wall, but you can't have window wall. So this means, Cascadia was again here every step of the way, helping with the modeling, supporting RDH when they had to get all of these conditions modeled in order to make this project work. Oh, and by the way, did I mention these are big? 13 to 15 foot spans here, all factory built, unitized. The only other option here was a very expensive, highly engineered curtain wall system. And so Cascadia came in to save the project cost. So pretty isotherms. Everybody likes to look at isotherms. But the point here is what Cascadia offers is not only the PHI certified performance, which there are many, many products out there that are PHI certified. But when we take into account the size and scale and things that need to be done on large commercial buildings while maintaining that PHI certified performance, there really isn't another option out there that can do what Cascadia does. And we do the modeling to support those conditions. So back to my my comment about internal reinforcing. On the left, you can see a PHI certified model of a vinyl window product. And this is what shows up on your building site as soon as you go outside of that modeled size of window. You have steel inside the frame all the way around. And just to show you kind of the magnitude of that impact, I've got a Cascadia modeled condition on the right side here, showing a mullion that's been reinforced with steel, which we would do in, say, like a corner situation where there's high design pressures and large spans. That piece of steel changes the U value of the Cascadia mullion from 0.8 to 0.9 level of watts per square meter to 2. So it's more than doubling. So that internal reinforcing has a huge impact. Not to say that you can't do it. Of course you can. You just need to be aware and have the modeling and account for it. And ideally try and avoid it in the first place. So once again, back to what's making Cascadia unique is the size and scale of the factory built glazing that we offer at the passive house level. What you're looking at here is a photo taken during the full-scale performance mock-up that was done of the window wall system. So we've really done above and beyond real testing to prove the capability of the system. This photo was taken during the seismic portion of the test. So some of the things that are tested on a commercial system that would, a residential window would never see is this large format. We've got over 20 feet of glazing here, withstanding very high positive and negative pressure loads with zero leakage, our passive house leakage level, as well as very high pressures for wind-driven rain. So, imagine blowing 100-mile-an-hour winds rain directly at the system with zero leakage to the interior. As well, the whole thing is frozen for multiple days on end to ensure there's no condensation issues or weak points. And then seismic movement. The 2 stories are moved, or I guess interstory drift is simulated just for a regular service life of 1.5 inches in either direction. And then the system has to withstand 3 inches of movement to simulate a seismic event to ensure that it's not dropping things on people when they try and escape the building. So you can kind of see on the right side here how the flashing around was bent by this test. And the Cascadia system still stands operational afterwards. So all these things, which normally a curtain wall is only expected to do while maintaining that passive house performance, is really incredible and unique. Back to Ken Sobel. So now that we have some Cascadia product context, I wanted to just look at the requirements again of this project through that lens. We've got high-rise, waterfront exposure in the lake here, cold climate. Hamilton has to meet the cold climate criteria for Passive House, so extreme thermal needs, as well as thermal stress on the system. These are black windows, temperature ranges, expansion, contraction, all of that stuff. There's really, when you think about it from the owner's perspective, what else could they have possibly used to meet all of those criteria at the same time at these 10-foot large opening span? There really wasn't another option. Also note that had the window wall been available at the time, it would have likely been able to address these slab conditions as well. So on to my second topic from Ken Sobel, which is the windowsill thermal bridging. This was the solution at the time. Fiberglass angle, great solution. What's strong, structural, low conductivity that we can put in there instead of a steel angle? Fiberglass, great solution. However, this involved a lot of help from Cascadia engineers, highly engineered solution. And it came with its own challenges. So what did we learn from this? Fast forward to another brand new project just coming out of the ground now, Gladstone Village Social Housing, also a Passive House, having to meet Passive House criteria. So wanting to push those windows out into the thermal envelope. So like I said, Passive House, high rise, very similar criteria to Ken Sobel, as well as very large openings. We're trying to maximize the fresh air and open area for the occupants. So instead of this custom engineered solution, why not take something that's ready to do this out of the box? Look at the Cascadia clip. It's pre-engineered. It loves sticking itself to the side of the building and holding really heavy things like cladding. So why don't we try putting that under the window? And that's exactly what was done. It comes in a ton of standard sizes, ready to go. Nobody's got to cut it on site. So this is what the Gladstone project team ended up doing, was taking this fiberglass angle, which was originally in the design, and swapping in the Cascadia clip. You can see to make this work, there is a little aluminum angle here at the front end, which supports the shim surface of the window, but it's all thermally broken, not connected back to the structure. And it changes it from a continuous thermal bridge into an intermittent thermal bridge at the sill of the window, further improving the thermal performance. So here's what it looks like kind of on a bigger scale, including other envelope components. You have your window support clip, and then your cladding support continues on at whatever depth it's needed for the rest of the project, holding that vertical girt in this case. And then you can have your flashing connect back to the window while not creating any kind of a thermal bridge back to structure. So what you end up with here is a essentially thermal bridge free sill connection by Passive House definition, which has been thermally and structurally modeled by Morrison Hirschfield Stantec. Shout out to them. You can have those reports to use them on your project. The structural modeling has been done, or both have been done, for multiple backup wall configurations, concrete, steel, whatever, to give your engineer the confidence that this can be used in any situation, a building type, with any size window, as big as you can build. It can handle it. And to further provide reassurance to any architect looking at using this, we built a mock-up in our factory with our water penetration testing setup, and tested this to our standard 15 PSF water penetration resistance. So it just looks like this with the clips, and then you can see the standard strap anchor connecting the window back to the rough opening for that inward-outward force. And then we have the backer rod and primary interior air and water seal there, still fully capable of doing its job in this exterior position. Another thing to note is this is kind of a Cascadia specific configuration I'm showing you here. The Cascadia window is designed to support itself structurally, and just use fasteners and the strap anchors to tie it back to structure. So it's okay hanging out here by itself. If you use another window product, the solution may not look quite like this. You may need Cascadia clips all the way around, for example, if there's openers, just to avoid any kind of torsion or whatever. So that may need some more engineering. All right, UVic. This is another project that has been profiled over and over, and shout out to Maureen Sanchez at RDH, who has presented this many times, much better than I could, so I won't try. But here is the building, and the Cascadia specific solution that we were able to provide here was to answer the need for big openers, as much fresh air as possible into these student dorms, while also acknowledging there's a serious space constraint here. We can't just go with our typical in-swing tilt and turn window. So again, the need for high performance outswing was critical in this project. There you see them. And fun fact here was, we had to work with our team to adjust and customize all of these restrictors to maintain the 4-inch gap for fall hazard, while also getting past this thick exterior insulation and giving the occupants the fresh air they needed. As you can see, itty bitty living space, no space for in-swing windows there. This next building I'm going to talk about is the PAE living building. So it is not PASFO certified. However, for anyone not familiar with the living building challenge, living buildings are pursuing many of the same ideals as PASFOs, and then some. So we've got energy efficiency as a target. Just like PASFOs, we've got the need to provide for all of the energy needs with the renewable available on site. In addition to that, we have very stringent resiliency needs, ability to withstand climate events and the building has to last 500 years, as well as carbon. So like LCA analysis and embodied carbon analysis was done on this building. So Cascadia's long life, 80-year modeled lifespan was critical in having it be part of this project for those reasons, in addition to the size and customization we were able to do for this team. So we have motorized operators on all of the openers, which tie back into the HVAC system for natural ventilation. And natural light was a key part of the design goals. So big windows, all of these are 10 feet tall. You can, here's some people for scale. Fun fact, the carbon analysis done on this building, now this is located in Portland, Oregon, so fairly mild climate. However, they did consider triple glazing on this project, and the embodied carbon analysis came back saying that any gains operationally that they would have gained by going to triple glazing were offset by the setback of embodied carbon caused by the triple glazing. So interesting tidbit there. And this project has tons of information online, and you can tour this building as well for educational purposes. Okay, really excited to get to the Q&A. This is my last project that I'm going to highlight here before we get to the Q&A. And again, this is not a PHI project. However, it is located in Vancouver, BC, where we have the STEP code, which is modeled after the Passive House standard. Same, energy footprint targets and principles, blower door tests, all that stuff is required. Now, the extent of this retrofit is so significant that it had to meet the current BC STEP code. And I think most of the outcomes are what Passive House projects try to achieve. So I'll tell you how that happened. Again, like Ken Sobel, we have the challenge of existing constraints. This is an existing building. You can see here, there's a lot of glazing. There's a lot of glass. We can't just improve our performance by, increasing the wall area. We have a real occupant comfort concern in this project that has to be addressed. these old aluminum windows are cold and drafty. People are not happy. So it's not just a theoretical comfort zone we have to create. We must improve it. Also, we have energy efficiency targets of the BC Step Code, which are very stringent. Looking at the existing building, very mullion heavy design. This is not what we want to see with high thermal performance. Those are weak points of the frame. So it's thermally inefficient as well as cost for any system that's trying to match that. Thankfully, the fiberglass system is plenty strong enough and high performance enough to do bigger windows and eliminate or reduce the impacts of those mullions. So to show you what I mean, you can see on the left, lots of vertical and horizontal mullions and small openers. Using the Cascadia system, most of those mullions were removed for cost and performance reasons, and those openers were made full height to give the most amount of fresh air possible. Everybody likes a good before and after shot, not only high performance, but also beautiful. You can imagine the improved views. And lastly, to finish off with the success of this project, while it wasn't PHI, like I mentioned, it achieved kind of everything that Passive House is trying to achieve, which is health and comfort of the occupants and thermal performance. And we know this from the actual owner feedback now. This is a building that's lived in now for a year, over a year. And the occupants have reported increased, they say, oh, I'm so comfortable. I can sit beside my windows for the first time ever. They're so great. Oh my goodness, these triple glazed windows are so quiet. It's amazing, the improvement in their quality of life. And to kind of finish it off, they've all been very happy with having their energy bills at a third of what they were before. So a huge success. So that's all of my examples. Hopefully we've got enough time in the Q&A. I've got lots of other information we can talk about with you curious types, but I'll leave you with my takeaways of windows are really important. Think about them early. Focus. Windows will help to set you up for success by setting them up for optimization. Also, pay attention to your details. Like I mentioned, what's on the certificate is not necessarily what you get in real life. Get with your manufacturer to make sure it's meeting your needs. And then Passive House makes a ton of sense for commercial buildings. It's not just a residential standard. And Cascadia is here to help make those commercial projects optimize. Thank you.
Fantastic, Sylvain. Thank you. Really tremendous presentation, and you've generated a lot of questions, so we should dive right in. Before we do, I also want to give a big thank you to Cascadia Windows and Doors for being a champion sponsor of Passive House Accelerator and supporting our work. It just means a lot to us, and we really appreciate that support. So in addition to being industry leaders, we're really grateful for that. So I know that Kara has been diligently keeping a queue here of questions, and the first one up is Claude Gerstel. Claude, are you here? And can you? Let's see. I do not see Claude actually. So next up is Anna Young, and it looks like Anna's here. So Anna, if you could unmute yourself and ask your question, that'd be great.
Yeah, I asked so many questions that I can't remember which one it was, which one I actually had on the list there, because it's a fascinating presentation. I think my first question was about EPDs and whether they were available for Cascadia windows, because embodied carbon and carbon storage is a big focus. Chris has responded that they are all available on the website, which is just great. So I will hit there and check that out.
Yes, again, there's so much to say about EPDs. It's such a growing area that's very important, but it's also a bit of the Wild West out there right now. So, Cascadia is very proud to have the first window EPD available, published under the brand new and approved window PCR, which was created by a big group of industry participants, window glass manufacturers, to make sure that the rules made sense for everybody that we're going to be following for producing these EPDs. So yeah, note, it's a good thing we have the EPD. We're the first one, but it's also, be mindful that any other EPDs you're looking at are not according to those new PCR rules. Great
Excellent.
question.
Thanks, Anna. Yeah. Next up is Kyle. Kyle England. Kyle, it looks like you're here. If you're able to unmute yourself. If not, I can ask a question on your behalf. I think I'll go ahead and do that. So, shoot. Okay, here we go. And this may be answered already, but Cascadia supplies across Canada, manufactured in the US or in Canada. For example,
Manufactured
tariffs.
in Vancouver, BC. Yeah. Manufactured in Vancouver, BC.
Yeah.
Thankfully, we've had really no impact from this whole madness. Our product is, like I said, manufactured and ships out of Vancouver, BC, but almost entirely sourced with North American components. So, if anything did happen, we would be likely on the list of exemptions just due to high content of stuff across both borders, or both sides of the border.
Excellent. Yeah. Awesome. Great. Thank you. And Steve Ferrero, you're up next.
Yeah, maybe another US-based question is about the Energy Star 7.0. Has that increased sales or opportunities? And, are we eventually going to get away from singles and doubles altogether? And will the world finally realize triples are the way to go?
That's a good question. I would say Energy Star is not something that we pay attention to specifically. We always ensure that we have it, that our projects are able to get it if they need it. But believe it or not, there's many areas now where you can't meet Energy Star without triple glazing. That being said, as I showed you with the PAE living building example, triple glazing is not necessarily the best solution for each project. It does come with limitations, like glass size, for example. You're limited to 40 square feet versus 60. So there's many things to consider with the glazing, but Energy Star is a key component. But I would say, no, we haven't seen specific increase in interest due to Energy Star. It's more Passive House. And the energy standards that model it, like the stretch code in Massachusetts, we're seeing a massive rapid increase there. Toronto Green Standard, similarly, Ontario, as you saw with the Ottawa project, interest increasing dramatically.
Thank you.
Thank you, Steve. All right, Craig Vireg, you're up.
Hi, thank you for your presentation. I was wondering if you could talk a little bit about fire resistance of fiberglass compared to other window materials. Thanks.
That is a great question. There's so many aspects to that. I would say, any thermoset material like fiberglass, thermoset by definition has higher heat tolerance than many other plastics out there. This we see, like silicone, for example, is a type of thermoset plastic used in high heat applications. However, it all depends on the fire requirements that you need to meet for your project and the fire testing. There's limited fire testing, I would say, on windows as a whole, and very few windows that are not made of steel that can pass any kind of actual fire testing for a fire window. That being said, if depending on the requirements, you can get frames, our frames with a fire resistant lineal. There's an additive that gets added to the fiberglass to improve its fire resistance. I can tell you from seeing the results of fire testing for the Cascadia clip, for example, that the fiberglass doesn't melt. It just turns into like what you would imagine from a piece of wood, sort of chars. It just chars. It doesn't melt or deform with fire. So yeah, I'd be interested to chat more with you about the context for the fire question.
Oh,
In terms
the
of
context is that my house burned down and I'm rebuilding it.
oh, so yeah, so
Jeez,
that's a very
Greg.
real
Yeah.
and practical context for wanting fire resistance outside of any regulatory or code requirement. So yeah, I would say fiberglass is we have replaced several windows in homes in remote areas where there was concern about fire. So it's definitely a material to consider.
Okay, thank you.
Yeah, thank you, Craig, and thanks for being here with us. And I'm sorry about what you're going through. Okay,
Thanks.
so yeah, absolutely. Next up, we have Becky Denio.
Hi, thanks. Yeah, actually, my question was pretty much the same as Craig's.
Okay,
Thank
great.
you.
Yeah, absolutely. Thank you. Now we have David Heavy. Sorry if I'm mispronouncing that, David.
All good. EV is the right one, but no worries.
Okay, Heavy, great. Thanks.
My question was about the price difference from fiberglass to aluminum spandrel. They compare.
Specifically fiberglass to aluminum spandrel. I can honestly say I've never been asked that question before. It's always about the whole system. So if you're talking about the window wall system, because that's where we have typically spandrel areas, and I'm assuming you're comparing a high performance product to a Cascadia product. So typically, the Cascadia system comes in less than an equivalent thermal performance aluminum system, just due to them being highly engineered and typically coming from Europe. If you're comparing Cascadia to a typical commercial aluminum system that is lower thermal and air and water performance, then there's a range of premium that you can expect there, depending on the product. But we're pretty consistently more expensive than those types of products for good reason.
Would you assume maybe double the price or?
No, not double. We're talking like, for less than a high performance aluminum in the 5 to 15% less to, I would say maybe 20% more for the commercial aluminum systems up to that percentage. That being said, I just quoted a project the other day against a typical Conair double glazed storefront system, far inferior performance. And when the installed price came in, it was Cascadia came in less. So you never know. Just check for your project. We can easily take a quick look and see where it might land.
Well, thank you.
Fantastic. Okay, next up is Martin Kropf. Martin, I believe you're here. Yep, I see you unmuted. I'll give you another moment. Okay, I'm going to go ahead and ask the question for Martin. He asks, curious as to why a fiberglass angle was not used instead of aluminum.
Oh my goodness. I am assuming where you're talking about is in this situation here. I'm not 100% sure about the context.
I'm not 100% sure either. Yeah.
Oh, I would say
so he says yes on the window with the clip. Yes.
Yeah.
Thanks, Martin.
Because I think much like how the sill angle was replaced with the clips for ease of procurement and engineering and basically ease. The same reason why we would use aluminum here. It's just easy to procure, easy to fabricate. cut on site, etc. And because it's completely thermally broken, in the thermal models that were done by Stantec, it really had no impact to the performance of the sill support. So just a practical solution in this case.
Perfect. Thank you. Thanks, Martin. And
question.
next we have Angela.
Hi, thanks again for the presentation. I guess my question was if you typically work with these firms in the more tender stage, or sometimes like earlier with the design development for all the modeling that's done so they can compare different window options. Thank you.
Yeah, I always tell architects to get Cascadia involved as early as possible. I'm often talking to architects in schematic design just to get our impact or our input into the design. What often happens is they will get through the whole design process based on a less capable window product and be limited in configurations that drive up cost for Cascadia instead of optimizing for our big size and structural capability. So absolutely get us involved early on, and whenever it's appropriate for us to support in getting the input for the modeling, we absolutely will get involved.
Excellent. Thanks, Angela. Up next, sorry, I need to get my list up here. John Snell. John.
Hi, I wonder if you could talk about residential front entrance doors, like a traditional architectural aesthetic, not patio doors, but more like a half window and a fiberglass frame with a wood appearance.
Good question. We do not offer that. That's an easy answer. Cascadia has, we have residential doors for patio and still in the movie here, for residential entry and balcony applications, but they're all fully glazed like this. So you could have a simulated divided light, but you're not going to get a half fiberglass, half glazed window. In an outswing. We have been asked to provide like solid panel doors before, which would be like a custom solution that you could have of various colors or potentially a skin on. But in general, no, it's just a painted frame with full glazing is what we offer for residential entry doors and patio doors.
Any suggestions of who would go to for that kind of a more traditional wood-like appearance for a front entrance?
That's the doors are a tough question. There's not many Passive House level performing doors out there, and I unfortunately don't have a recommendation for you off of the top of my head like that for a wood look, other than actually getting a wood door.
Thank you. Yeah, we're running into the same problem of just not finding it, but thank you.
Yeah,
Thanks.
I mean, at least we've got you covered from the thermal aspect. Unfortunately, our aesthetic is limited with our focus on just the performance and the commercial market.
Perfect. And John, you have a couple of responses from others on the call, so there's some
great
some leads there for you too.
Crowdsource this.
Yeah. Okay, so next up is Pablo. And let's see. Pablo, looks like you're here. Pablo Rodriguez. And your question. I'll go ahead and ask it. So 3 parts. What insulated material is used inside the cavities? How is this profile recycled or treated at the end of life? And how the corners are connected?
Oh, good questions. So firstly, the insulation. So it is a foam, and depending on whether it's certified or not, depends on which foam we put in there. I don't want to speak improperly and say the wrong polymeric name for the exact foam that it is. However, you can jump to our red list free or declare label here to see the details of the ingredients, the ingredients of the window. But, you know, if the concerns are about VOCs and toxic, etc., it's rest assured it is red list free. For some reason, this link is not working. I apologize. The end of life situation. So fiberglass, our windows are designed to last forever, last as long as they possibly can. Fiberglass is a material that enables us to offer that. However, it is currently not recyclable. The assumption in our EPD is that it goes to the landfill when it's done. And I think in reality, that is what happens to all windows, no matter how recyclable they claim to be. There is no real waste stream for full recyclability of windows as of yet. So that being said, end of life landfill, also non-toxic. If it does go into the landfill, you know, we're not going to be seeping things into the environment. So it's a very inert material, fiberglass.
Sylvie, I'll jump in on that one too, that all of our frames actually have 58% recycled content in them. So rather than worry about what happens downstream, we've really prioritized making sure upstream has as much recycled content in it as we can.
Thank you, Chris. Our marketing director, Chris, thank you. We also, for the corner question, the corners have shear blocks inside to give them added strength. So fiberglass is not a weldable material, so it's just good old joints and sealant and shear blocks in there, which give it its strength and performance.
Excellent. Thank you for those, Pablo. Next up, we have Chie. Chie, great to see you.
Great to see you, Zach. You mentioned that the max size being 13 foot to 15 foot tall. What's the width, the max width?
That's a great question. Typically, you can go based off of the limits of your glass. I would say starting your design with a 10 to 12 foot height, you're probably good. And then up to, you know, a 5 foot width is probably pretty standard, but you can quickly check. There's multiple factors that play into the size. There's the limits of the glass IGU that we're putting in our window, as well as if it's a window that's spanning like these, with the deflection limit of that spanning member based on the height, the width that it's spanning, and the wind load. So the design conditions specific to the project. So we would check all those things, but you can see sort of the hard limits, which are based on what we have actually physically tested. Because this is a factory built product, we're limited to what has been tested for maximum sizes in the lab. So that you can see here, you know, we have if you have a 12 foot tall window, you can go 60 inches wide without a mullion in that unit. If your unit is 10 feet tall, you can go 70, so you can go a bit wider. If it's a little shorter, you can go even wider. You know, that's within the square footage limits of the glass.
Okay, got it. How many can you mold together?
Well, if you look at this project here, for example, some of these spans up on the top here, continuous mold for over 100 feet of width. It's really what can your structure above the window manage in terms of deflection and structural load. So the window is not in itself, the window system, you can you know, mull it as far as you need to.
Okay. And this question you may not be able to answer, but I'm going to ask anyway. I understand that different fiberglass materials from different manufacturers have different strengths. And one thing that I've heard from a different manufacturer was that the strength of the fiberglass is dependent upon the percent of roving or the strands of fiberglass. Do you know what percent roving you have in your material?
I do, and I'm sure this is something that Chris is feverishly looking up right now. However, I would tell you that to focus on little, you know, material composition elements like that is kind of getting into the weeds, because what ultimately gives your window its strength and performance is the design of the profile. Like how much fiberglass is in there. If you look at a Cascadia fiberglass versus other residential products, you'll see there's a lot more fiberglass in the frame. It's beefier. And for that reason, you know, you should look to the test results and the design pressures that it's capable of withstanding. Not so much the, the ingredients that go into the recipe.
Okay,
I would
okay.
say.
And
I wouldn't
earlier-
discriminate against windows just for that number.
Right. And earlier you mentioned that the limits of the size is a function of IGU. So do you get yours from Cardinal? Is it Cardinal IGU?
We have a range of IGU fabricators that we deal with. We have a handful of them. I think COVID helped push that along. But we do, Cardinal is our primary IGU provider for, the majority of projects that don't have any crazy fancy glass. But we do have options if your project needs Guardian, Vitro, others, and we can, source others if needed.
Okay, thank you. And by the way, I live in a certified passive house with Cascadia windows, and I'm happy with that. So thank you.
Oh my goodness. Oh, couldn't have asked for a better question asker. Thank you. Where is can I ask where your building is located?
It's in Santa Cruz, California.
Oh, nice. We'll have to come for a visit.
Sure, let me know. Give you a tour.
Amazing.
Thank you, Chie. That's great. All right, next. Oh, actually, we should do a quick time check, Sylvain. It is now 15 after the hour. Are you okay time-wise to continue,
I
or
am
what's?
okay.
Okay, great, fantastic.
I'm
'Cause
so
we
jazzed
have
by all this enthusiasm
we
and
have
questions.
we have a lot of great questions. So next up is Elroy.
Oh, I think you skipped me, Debbie.
Oh, great, Debbie, please
I
do.
won't be too long, but I just
Yeah,
have to
yeah,
say I love the window walls. I was definitely keeping up with Cascadia, but it was a long time ago now. So the PAE, building there in Portland reminded me of that. So, and I asked a question about seismic, but I think you kind of answered that. I asked a question about Meridian as far as the number of units and kind of the cost of just the windows in that project. Chris responded that he might have a number. But I did want to ask, I work for DoD. Do you have blast-proof hardening type of glass as well? Since I didn't put that in the chat, but I think all my other questions were kind of answered.
Yeah, glass is often where a lot of the complexity comes in on projects. I would say for blast specifically, that's a tough one because often what's required is not just a blast proof rating from the glass, but from the frame and the whole assembly itself. Cascadia doesn't have whole window testing for those kinds of things. Just like we don't have a ballistic rated window, we don't have a blast rated, we don't have a like hurricane, like projectile rated window, but you can put those kinds of glass in our windows if you're able to have that kind of workaround for your project. If there isn't like a hard whole window requirement, we're just supplying right now a middle school in Lake Oswego with ballistic, basically active shooter resistant glazing, which is of course tragic but necessary, and we're able to do that for them because they didn't have a requirement that the whole window meet some kind of a test standard. So
okay.
I would say, yeah, we should look into it if you think there's some flexibility.
Galley. That's the only place everybody goes on this particular part of the base. So I think that's where that hardening comes in, because everybody would be there 3 times a day. But as you're saying, maybe when we do a PHPP and we can analyze, maybe we can go with the lower performing glass and still get that, right? We just have to kind of play the game at that point. I'm mechanical, so sort of, have to look at the numbers.
Oh, nice.
Yeah.
Mechanical.
Okay. I know that's a weird question. I'm sorry to get us off topic, but
No,
it's
it's
actually a
not a
project
weird
we're trying to
question.
put together right now. So, yeah.
Yeah, when you're trying to like blaze the trail, sometimes you gotta work through the hard questions. So we've done it.
And I want to be able to give positive answers back to my base people and not like we can't find this glass anywhere and not do a passive house approach on this building. So thank you.
Yeah.
Appreciate it.
And
Love
I would
the
say,
window wall. Love it.
something
Love the
that
solution.
Yeah, something that might trip us up is I don't know much about blast resistant glass, but if it's extra thick, for example, because we have a factory built system, we have a finite number of IGU cavities, like sizes that we could fit in our system. So if it's too big or in between some of the sizes, that could pose a challenge.
Yep. No, totally appreciate it, and love the window wall for other projects that we've been looking at too. So thank you again for the
Great.
time.
And Debbie, I'll take your name down because we are looking at hurricane testing later in the year. So we're just starting to go down that journey that as I know more, I'll just send you a quick note.
That would be great. Thank you so much.
Thank you, Debbie. And sorry we almost missed you. I'm glad that you got your questions in.
Yeah. Sorry, I really wanted to ask about the blast.
Yeah,
proof.
no, I'm glad. I'm glad. Thank you very much. Okay, next up is Elroy.
Oh, thanks very much. I've
Yeah.
enjoyed the presentation so far. I'm a newbie in the passive house world, but looking at integrating that into my house design. We're currently just in our application process, so we hope to get there. Looking at ICF, how well does this system integrate with ICF, and how is Cascadia structured to help individual owner builders like myself?
Multifaceted question. I would say Cascadia is set up to integrate with any kind of wall structure system. The only thing our window cares about is that it is structurally supported, that it is properly fastened, and that it's properly sealed. So how you do that, how that integrates with the rest of the envelope is like up to you and your architect, but we do provide a lot of details for you on our website here that you can refer to. Lots of downloads. If you want to look here, for example, there's in PDF and CAD format. You can see, now this is just a typical installation example. It's neither high performance nor low performance nor good nor bad, but it does show you kind of what the Cascadia window needs, which is fastening, support, and seal area. So, provided you kind of follow that, then whatever goes around all of this area and how that integrates is kind of up to you. We have a membrane connection here back to the interior seal, membrane connection here to the back dam angle. Yeah, like I said, whatever goes on either side of that. It's very flexible.
And for technical support, you have people available to answer annoying questions from individual
Absolutely.
people.
We have a high tolerance for annoy. We have lots of geeks on our team. So we also do have a ton of resources here for like videos if you want to know how it gets installed. This shows the full install sequence, including waterproofing, which is not part of our scope, but we show a good practice. Mulling the windows together, assembling doors, etc., fully rendered. So that's there for you. And should you have a project where you are going to use Cascadia windows, we do provide like a multi-step interaction process with our clients where we make sure everybody understands what they've ordered. We make sure we go through detailed shop drawings so that you know the specific details. And then we have an install training with whoever's actually going to install the windows prior to shipping the windows.
Two more short questions. Your doors, they're tilt and turn inside, or do you offer tilt and turn doors?
Yes, our doors, the slider doors are tilt and slide, so they can tilt in and then also slide. They can be inward sliding or outward sliding, in which case they don't tilt. And the swing doors, you can also, the in-swing version can also be a tilt and swing door. So you can see the action of a lot of those. There's some links somewhere on here. Gosh, getting my finger excited. Yeah, if you click on these links here,
door. Fantastic.
you can see videos of the operation if you're curious.
And then I saw another question come up on the chat that would also apply to me. UV resistance of this fiberglass. Can you speak to that?
Yeah. Extremely resistant. emphasize that fiberglass is very resistant naturally to the elements, both through just the material, thermoset material itself, but also because we use the highest quality, highest rated coatings on our fiberglass that are available on the market. So we have what's called an AMA 625 rated. That's
Yes, I
really
just
the
dropped it in the
highest,
chat, Sylvie.
highest rating for, abrasion, UV salt spray, whatever. And for this reason, fiberglass is used a lot in like the Arctic coastal environments because it just really doesn't care about the elements. So yeah, we also see a lot of interest for otherwise non-high performance areas like Arizona, hot places that get a lot of sun for the thermal resistance.
And do you have distributors out in the Kootenays in British Columbia, or are you direct from Vancouver?
We do not go through distributors, so we supply directly to whoever's going to be installing the windows. So in BC, that's, we do have an install team. In British Columbia, and then otherwise we would supply the windows directly to the homeowner, the builder, the contractor, installer.
Fantastic. Glad I stopped in on this webinar. Thank you very much.
Oh, thanks for coming.
Thanks, Elroy. Okay, next is Cody.
Great presentation, Solveig.
Hey, Cody.
Hey.
I like your jacket.
Thank you. Rather cold in here. Just got a question about your Gladstone project that you mentioned. You mentioned that they switched up the window install to use your Cascadia clip to support the window. And I'm just curious what the main driver was for the team to go that route. If it was more the structural capacity, if it was, if there was some energy savings we found with a lower psi value with the install, did that, that help maybe reduce the wall insulation or something, or, create some sort of other savings for the project?
It's a great question. That answer is to be confirmed because this is currently being, still the thermal part of it is being analyzed by RDH, but I think it was just enough of a sort of ease of use switch for the installer, because this is actually in the installer's scope, putting in the window installer, putting in this angle, that they were like, yeah, that makes sense. And I think we had provided all of the thermal and structural modeling up front. We had our glazing engineer, look at the angle. It turned out they would actually have had to beef up this angle over what was designed. It was under designed as it was. So, the combination of, in reality, increasing costs of this and then increasing simplicity of this solution and the clear structural capability, I think, demonstrated with the report and our engineer backing it up, just made it really an easy choice for them to okay.
And was that process pretty easy for their engineer to look at this and not be, scared with the innovation of it and, not seeing it before? Were they able to analyze that no problem?
So it wasn't their engineer, it was, I think, the fact that we had so much support that we offered up front that made it easy. So the combination of the Stantec, Morrison Hershfield Stantec structural report, as well as our engineer looking at this specific scenario and saying yep, you'll need this many clips, this side with these fasteners for your backup structure. I will sign off on this kind of thing. Yeah. That just gave everybody reassurance that it would work.
Just hand it on a silver platter. Nice.
Exactly. Hand it on a silver platter. That's what we like to do.
Perfect. Thank you.
Thank you, Cody.
Thanks, Cody. Next is Richard. Richard, how are you?
Good, thanks, Zach. Thanks for taking the question. This is probably on this building that I'm looking at, a small residential house for retrofitting. To try and keep the costs to manageable level, would it be better to go to some pre-planned, pre-made, or off-the-shelf type windows to put into this situation, or adjust the rough opening to accommodate those, or to have the windows specially made for the dimensions required?
If you're talking about Cascadia specifically, our windows are all custom made, to the millimeter. So there's no sort of benefit by using a standard size. I would say you can get you can get cost efficiencies by making all of your windows one or limited number of sizes on the project, but I do not, you don't have to size your windows based on any kind of standard size from Cascadia.
Or the IGUs. Okay, thank you.
Yeah. Bigger the better for cost per square foot.
Excellent. All right, next up is Campbell. Campbell, I see you on the call. I don't know if you're able to unmute yourself. If not, I can ask the question for you, rather. I certainly can't answer it. Okay, so Campbell asks, do large window assemblies need to be shipped in pieces and assembled on site? Or what are your size limitations based on shipping/trucking?
Great question. Yes, depending on the size of the window, they do get broken up and assembled on site. Where that happens is usually to do with handling. Excuse me. There's a couple of limits. There's how much weight do your installers want to handle on site? What equipment are you prepared to have on site? And then there's the limitation of what can Cascadia actually handle in our factory, which is usually at around 500 pounds or so. So take, for example, I've got this crate for that middle school that I was talking about earlier. I'm trying to grab it here to show you. Give me a second. For some reason, I'm not able to grab this, but there we go. So here's a nice crate about to go out. Like, these windows are going to be attached to each other along this side. They're going to be flipped up vertically and mulled together along this side on site, because those are each probably 400 to 500 pound windows. And they have components that are used to connect those together that basically become invisible once they're installed and just looks like a mullion. And they are crated, and we use the strap anchors to attach the windows to the crate. What does that? Hopefully that
Excellent.
answers your question.
Yeah. Fantastic. Okay, so next up is Steve.
Yeah, you didn't mention much about the low-E coatings and driving the R value up by using higher performance coatings. And also, relative to the last question, is a lighter weight material other than glass, would there be value in that?
Lighter weight material other than glass. Are you hinting at like opaque materials or?
No, for transparent coated materials. If there were a material that had a higher performance than existing coatings, and are you coating agnostic, or do you work with an IGU manufacturer and you just will use whatever meets these specifications?
We certainly work with specific IGU manufacturers that mostly from like supply chain quality, reliability, track record reasons. Also, we have to supply what's shown in our NFRC thermal. We can't supply anything that's not thermal modeled and that meets North American standards for that kind of stuff. So for that reason, we're not, just popping in any kind of newer or experimental products. That being said, we have just recently launched a product which has reached its level of, track record and ability to be launched, which is vacuum insulated glazing. So that I would say is the kind of new wave technology that everybody's been kind of waiting for. It's still in its infancy with Cascadia, but it's very promising, and we're seeing R12 with our windows, that kind of situation.
Okay.
But yes, for low-E coatings, for everybody dealing with projects today, you've got a lot of flexibility while maintaining essentially the same U values with our products overall, and just playing with the different low-E coatings. You can tweak your light that's coming in and your heat that's staying out or staying in, and most of our suppliers have equivalents to these. So there's, these performance targets from Cardinal are pretty good to use as your guide for what you will want to specify, and know that you can find alternates with other manufacturers if you need other things from your glass.
Right. Okay. Thank you.
Like bird friendly, for example.
Great. Thank you, Steve. And Laura, you have been very patient. We are finally to you. How are you, Laura?
I'm good. I'm good. There I go. So hi, this has been a really good and very interesting presentation. We have been frustrated with European products that their locks are welded, so you can't rekey them. Whereas American and North American products have screws that can be rekeyed or master keyed and slave. So your locks and cams, how do they work? Are they North American type or are they European type?
Ooh, I can tell you that all of our hardware comes from Roto Frank, North America. However, it is a German company. So technically European style hardware. It's what enables us to offer all of the, tilt and turn functionality.
But
in our
can they be
in-swing
rekeyed by a local locksmith, or with the
I
European
don't
ones,
believe so.
you
And the
have to
reason I say
replace
that
the
is
whole
because
cam, which of
I
course
just
you
had a
can't
project.
do. Yeah.
Oh, sorry, we're
All right.
talking over each other. I just had a project where the owner lost the key to the front door in construction, and the fix was to replace the cylinder with the key. So we shipped them a new cylinder with the key.
All right, so that is a real problem, particularly in multifamily or whatever. And we're just a little 4-unit building, but I had really wanted to get rid of my gaggle of keys to have a slave and a master. And then of course, if someone's leaving or if you have an incident, and you want to change your keys, that it's just not practical. I would have to order one. It would take weeks or months to get it. You can't take care of security issues without the North American type. And I have someone, a metalsmith who thinks that he could maybe mess with it, but it's not a practical thing. And it's one of the real frustrations that we have.
Yeah, that's great feedback. Thank you, Laura. I would say that it's a slightly a non-issue for Cascadia, just because or less of an issue, I would say, for us, just because our residential doors are primarily used for entry doors for a single family or a balcony door on multi-use residential where they don't lock them. There's no locks on those typically. All common area doors, entries into, common area entries, commercial storefront, all that stuff is not done by Cascadia. We do not have a commercial door currently. So I think, you would be getting that type of a door with that universal lock system from somebody else. But still same, issue for the single family homeowners out there, for sure. Great point.
Thank you.
Cool. Thank you, Laura. Okay, we need to do another time check here. Sylvain, this is
how many people are
amazing.
hanging on still, Zach?
Yeah, this is quite the marathon. Are you good time-wise? We do have some more questions, but it also has been over an hour and a half. Or how do you need to be running to your next thing? What's your story?
Let me just check my meeting schedule. I think I have a pretty open schedule today because I
Solvay, the
had a
answer's no.
sneaky...
The answer's no. You can stay. Just keep going. This is awesome.
Okay, all right, fine.
Sneaky suspicion you guys were going to be keeners. But just give me a second here.
Yeah, absolutely.
No,
absolutely.
I'm pretty good. I got until 1:30 Pacific time.
Okay.
How's
Right.
that work?
Uh-oh, you shouldn't have revealed that. Okay, so the next question we have is from Anna Young. Anna, you're still here? Yes.
I sure am. It's fascinating. I really appreciate the commitment. My question was around carbon storage. Looking at these very high-end, high-performance windows, I'm interested in what potential there is for using them as a tool for carbon storage in the construction of a building. And they're wonderful on energy efficiency, but until we are looking at pulling carbon out of the atmosphere and putting it into our buildings, we're not as much part of the solution as we would like to be. And that's something that's easy to lose sight of. So I'm thinking, you know, insulation going down the road. And I also had a question about downstream reuse, recycling, design for disassembly and deconstruction, so that they don't go to landfill at the end of their cycle, their life cycle. And Chris has spoken to that a little bit, that is on the radar, but I'm interested in, you know, carbon storage.
That is a fascinating question. I don't know if we're looking at that carbon storage, but certainly if there's you know, materials that would be able to be used in a window system that also enable carbon storage that are not wood, you know, we would be definitely looking at any, you know, I think Cascadia, we just have always been believers in transparency and thermal efficiency and healthy materials and all that stuff. So obviously if something came to our attention, like what you're saying, we would look into it. Not aware of any carbon storage, you know, capacity to our windows currently.
For the conversations that I've been hearing about carbon storage, which is a really important, you know, important topic, and you know, I honestly could be a very exciting opportunity as well with buildings, has centered around things like straw panel construction, and looking at the decisions we're making about you know, natural materials in insulation, and then as well which is more complicated, but the potential of wood structure playing a role, at least in dramatically reducing the upfront carbon, but potentially depending on a lot of complicated factors around forest stewardship and production, potentially some sequestering, you know, through CLT and that kind of thing. I personally haven't heard of window components being discussed in that yet around carbon storage. It's really interesting. Yeah.
It is interesting. I would say if you're interested in wood and all that stuff, you should try attending the Mass Timber Conference in Portland. It just happened a few weeks ago, and there was a lot of conversations around this kind of thing. There are, you know, wood window systems, wood curtain walls. They of course, you know, are mostly for aesthetics currently, but you know, that conversation is definitely starting in some circles.
Yeah, we don't just have to concentrate on wood, though. I mean, bio-based materials is a field that is really exploding. Zach's nodding away there, which is great. So, you know, let's take it a little bit wider than just a wood application with all the issues that you've already spoken to for the disadvantages of using wood. I mean, there's engineered wood products, there's various different biofilms now coming onto the market. So I'm definitely interested in that. I will keep an eye on you guys and watch that space, because it would be great to incorporate the kind of performance that Cascadia has with also an element of carbon storage.
Yeah, that would be fascinating. That's awesome.
Yeah, thank you, Anna. Yeah, we appreciate you raising that. Okay, so let's see. Sorry, up next. I'm sure if you are still here, you know who you are. Kyle, you're up next.
Hi all. Thank you, Solveig, for the great presentation and the endurance to withstand all of our barrage of questions. I think I asked 3 of my 101 questions in the chat, but I think the second one was, is it cold? Are your products cold weather climate certified? And then the follow-up is, have you explored vacuum insulated glass yet for your products?
So no, we do not have a cold weather certified version of our product. That doesn't stop us from shipping our windows into lots of cold climates for passive house and non-passive house projects. But on the vacuum insulated glazing front, I do have a little bit of something I can show you. So we have recently partnered with a company called Luxwall to offer a vacuum insulated glazing version of our product. So you can see our standard triple glazing, passivos level performance here. We know that this overall performance is going to exceed R11 for, Chris, where are we at with the modeling? Has it come back yet?
It's still going on right now. I should have it back in probably 2 weeks or so, and then we're going to review. Honestly, the feedback so far from the modelers is that the software is having trouble understanding VIG. And so the physical testing that we've been doing is showing different numbers than the modeling. And so we're trying to figure out which one is correct, but we know sort of the lowest that we've seen is this R11 inside of our frame.
Yeah, as an effective window value, including the frame. And our feedback from Lux Wally, like when they decided to partner with Cascadia, was, look, we've looked at a lot of different window frames, and yours performs the best with our glass by far. So that's why, you know, we're partnering with them. They kind of chose us a little bit. And yeah, so this is exciting. It is high cost, I will tell you that. So not too worried about it, like competing with our regular Cascadia business right now. It's for us, you know, special situations where you really want really high performance and are willing to pay for it. We are seeing interest in it for retrofit applications where, you know, the current thing is they don't have as much flexibility to replace the whole system with the triple glazed system, for example. And this can be retrofit in, because it's essentially the thickness of a regular piece of glass. So in our system, we put the vacuum insulated glass in with another piece of glass to create a, you know, essentially a double glazed unit that has the performance of a wall.
Awesome. Thanks, Kyle. I think that brings us to the conclusion of questions. And I will say that Solveig, you have set a record for the component spotlight duration. We have gotten close to this, but never an hour and 45 minutes. So well done. Again, a big thank you to Cascadia for your support of Passivhaus Accelerator and for this tremendous presentation. Is there anything that you, Solveig and Chris, would like to leave us with before we close up?
I would just say that if you are interested in more information, if you'd like to set up a lunch and learn for your firm, or to set up a private webinar to learn more about this, just reach out to us, because we do virtual webinars. We'll organize to have lunch shipped to your office if that's something that's interesting, and then do it remotely. And we love to do the educational component, and obviously Solveig crushes it. So if you want to chat more, please reach out, and we're happy to do so.